So here for you chipmunks is another example, and this is a mixing example.
I'm ready, so let's go.
Okay, let's go. So recall the saltwater mixing tank problem from Unit 1, Lesson 4. There's a tank full of a substance dissolved in a liquid, and there's liquid coming in and going out of the tank. So liquid's coming in, liquid's going out, and here's the stuff inside the tank, and we assume it's well stirred inside there. So A is the amount of stuff in the tank, Rn is the rate of stuff coming in, R out is the rate of stuff going out, and that, with those representations, it's easy to see the model is the change in the amount in the tank over time is the rate of the stuff going in minus the rate in the stuff going out. So if we make an assumption that the tank is 300 gallons and there are 3 gallons per minute being pumped out, further assume salt containing 2 pounds per gallon is being pumped in. And I didn't say this somewhere, but I should have. At 3 gallons per minute, right? So at 3 gallons per minute. All right, so here we got Rn is 3 gallons per minute times 2 pounds per gallon, so 6. And R out requires thinking, because the rate out is 3 gallons. That's not a problem, but then how much salt is in what's out? Well, the amount of salt per gallon and what's going out is the amount of salt in there divided by 300, because there's 300 gallons in there. So, and the 3's here and here cancel, so it's just the rate out is A over 100. And we have the first order linear differential equation, and here it is. dA dt equals 6 minus A over 100. Further suppose there's initially 50 pounds of salt in the tank. Now we have the initial value problem. dA dt equals 6 minus A over 100 with initial condition A sub 0 equals 50, and we can solve it. So you should pause this video and try it now. Resuming from the pause. How to go from here? Well, to finish it, add this to both sides. We got dA dt plus A over 100 equals 6. The integrating factor is e to the 100th dt, and that means if we multiply both sides by this integrating factor, which is e to the t over 100, right? So multiply both sides of the equation by that, and then we get to the left-hand side. This part of it is just the derivative of e to the t over 100 times a, because here it is, first d second plus second d first, plus second d first. There it is. And the d first, that's 1 over 100, that's part of the d first there, so that's pretty close to what I was telling you. So now all we have to do is integrate both sides. Of course, when you integrate a derivative, you just drop the derivative. When you integrate this, that's a pretty easy one. So don't forget you'll be dividing by 1/100th, which is multiplying by 100. So you get e to the t over 100 times a equals 600 times e to the t over 100 plus c. And then dividing both sides by e to the t over 100, you get a is 600 plus our constant times e to the negative t over 100. Applying the initial condition at time 0, there's 50 pounds in there, enables us to find c. So 50 equals 600 plus c times e to the 0. C therefore is negative 550, and we have the complete model now. The amount is 600 minus 550 times e to the negative t over 100. So, question, how much salt is in the tank after 100 minutes? We'll just put in 100 for t. And how much salt is in there after a very long time passes? Well, that's going to require some thought. That will definitely require thought.
We better put on our thinking caps and think hard.
Yes. The 100 is not too hard to figure out, because all you have to do is put in 100 for t. And so if you wanted to figure out what that is, it's 600 minus 550 times e to the negative 1 times 1 over e if you want it, and it turns out to be about 397 pounds. How much after a very long time passes? Well, duh. There's 300 gallons in there, and it's 2 pounds per gallon, so there should eventually be 600 pounds in there. But you actually, if you wanted to say, what's the limit of this as t goes to infinity? Well, this is e to a negative power, so that part is virtually going to 0, so you just actually have the 600 there left.
Wow.
Okay.